Morning, everyone. My name is Rahul, and today I'm going to be presenting on the topic Look Twice Before You Run. It's a small presentation on why you should formally verify any software that you run on your servers. So, unlike the olden days, deleting the prod and backup data is not the only way to ruin your IT team's day. With the rise of AI and large language models, Microsoft claims that almost 50% of the code that's on GitHub right now is AI generated. What you don't know is that 50% of the code that AI generates has a lot of security vulnerabilities in them because of the kind of data they're trained on. Most of the code that's being written may be malicious on purpose, or it can also be written by people who are not experienced enough to write secure code, which means that when you use ChatGPT, Cursor, or any other AI to assist your coding, it might just be vulnerability as a service. So you need to be really careful on what code you push to your GitHub repos. It's especially prevalent with the junior and the interns who try to do vibe coding, where they code only using prompts and not look at the program at all, where it leads to disasters when it comes to application development. So cyber's all about adapting to the situation, right? We as cybersecurity professionals must adapt to what's happening at the moment. Access management before has protected the production database from unauthorized changes. We've had a massive improvement in backup protocols that ensure recovery and resilience of business operations during even the worst of disasters. But why is it that in the development phase of CI/CD pipelines and software lifecycles, that a lot of input is taken from the DevOps teams or the software engineering team and the managers, but not enough input is being taken from the cyber team, who's going to manage most of the inputs that's going to come as requests to these apps when they're actually on the servers? You guys have to actually look into what kind of requests are coming in and if they are use or misuse cases. So it's really important that the cybersecurity team is also involved heavily from the beginning of the development phase. How can this be achieved? By formal verification. So what is formal verification? Think of it like your program being turned into a switchboard with a bunch of switches. What do I mean by that in technical terms is that your program is turned into a set of Boolean math equations. So you have each statement that's being passed into low-level code that is kind of turned into a resulting value that results in either true or false. So it's easier for us to compare it against certain verification conditions or patterns that are most known common vulnerabilities. Think of buffer overflow conditions or type mismatches. I'm pretty sure the red team might actually understand a bit more of these, but if you are not much well versed in code, that's fine too. All you need to know is that there are certain patterns that we can find in a program that will let you know that yes, there is a high chance that it can be exploited. So using some open source tools or which are highly flexible and customizable will ensure that you catch these errors early on into the development phase before they are even pushed to the production. They are well tested. So when you use these tools in the CI/CD pipelines or when you encourage your developers to do so, you're not asking them to do software testing just for software functionality, but also for software security, which I feel that must have a bigger importance being placed on them as we go on. You can say, cool, but I don't make websites or software. Where can I use these tools? There are wide use cases for such tools of formal verification that just goes beyond everyday software development. You don't have to be in the software testing or the software development team to use these tools or incorporate them to your workflow. Are you defining network protocols for your routers? Are you defining network architecture that with a lot of config files in your home lab or maybe in the lab at your organization? Or are you handling cryptocurrency transactions in Ethereum and Bitcoin that are defined by contracts? A lot of the common people do not know what the Bitcoin contracts or the Ethereum contracts are, and if they want to make investments or if they want to do something with these contracts, it's better to verify them using these tools. Or you are working in a critical environment like healthcare or the time-sensitive systems like in a hedge fund where you define distributed systems, where a lot of these times these companies use time-sensitive systems where they have to make a lot of monetary transactions within seconds, and a delay of even a millisecond can cause a lot of loss for that company. So if you're going to write something that works at a critical environment, or if something that's of high importance, verifying that the applications work as intended and the system is distributed with resources as intended in the configuration files goes a long way. Or you can just use this in a CTF challenge to see if a code is vulnerable or not. The limitation is only based on what the tool is targeted for. And there are a lot of tools for it. Let's just go for an example, right? So I'm going to use a general C example of a C code. Nothing too fancy. I've simplified it as much as I can. If you can see here in this code, on the integer array, there are 3 values, and I'm trying to access an array that's a number that comes after the number 30, which doesn't exist. I'm trying to access a data that doesn't exist. So if we leave code like this unchecked in the GitHub profile, in the GitHub repo, which is eventually run on servers, obviously in this scenario, a compiler might catch it, but in large cases where there is a lot of memory handling, when such codes run on repositories, you can have arbitrary code execution, which is basically like a person can manipulate the memory to execute any code he wants or extract data that's on the RAM. So when I use a tool like ESBMC, which is one of the open source tools that's available as a formal verification tool, and I pass this code as a test input file, as you can see in the red box that's highlighted with the command, it gives me an exact counter example and the kind of vulnerability that's found in the exact line of code that is present in the software or in that particular line of code that's there. So it can help the programmers detect security vulnerabilities or like coding malpractices. And at the same time, it can allow for people who work in cybersecurity teams to easily identify errors in code, which can lead to a security vulnerability without having to read every single line of the program. So it's a tool that verifies a lot of C, C++ programs, or even Python and Java. It's versatile, and the current research of this tool also involves self-healing code with the use of LLMs. It automatically catches areas that are that have a lot of security vulnerabilities, and it kind of restructures the code and pushes it back to the repository so that it doesn't have so that the errors are fixed. Let's take a real life example of an Ethereum contract this time. The last example was a bit more simple, and this might get a little bit technical, but I promise it won't be too hard. An Ethereum contract, in a sense, is like a blockchain contract. So a blockchain contract is basically like any legal document or contract that's written in a program. Let's say I write a contract that says if I pay $1 to the other person, they might give me $5 back. That's a contract, and it'll be in a blockchain. King of Ether Throne was one such contract that was a very well-known Ponzi scheme from back in the day when Ethereum was just introduced, and it was the height of Bitcoin and blockchain technology. A lot of people lost money to this Ponzi scheme, but on a quick scan of that file using this tool called Mithril, which is also open source and it's really customizable, it tells you quickly if the code the exact line of code, if it's vulnerable, if the contract is malicious, or how exactly you might get exploited on paying to that contract or subscribing to that contract. So it's a lot of output here, but if you can see at the top, when I ran this using Mithril, it gave me a small summary of what that exact exploit is. Any sender can withdraw their Ether from the contract account. That means that any sender can withdraw the money that they've deposited into the contract, and arbitrary senders can verify the business logic carefully. It's just a lot of words that mean that any person who has contributed some money to the contract can take all the money away from it. So this might indicate the Ponzi schemes before you might fall for it if you don't know what you're actually doing. So how can you actively incorporate such tools within your workflow? You can encourage developers to add these tools into their CI/CD pipelines for automatic checks before pushing the code to the repository. Since it's not some heavy testing where they have to write unit testing codes for, it's not a big ask to ask them to add this to GitHub workflows or GitHub actions where this is automatically run, and it will give you an output saying where exactly you went wrong, and it's a small fix. So I feel that encouraging them to adopt these technologies and including yourself into the development process as a cybersecurity team. And I actively contributing to the security of the application during the development process can really help you out. There are general tools for verification in different languages. The two examples I've showed you is only for C, C++, Python, the first one. And the second one is very blockchain specific, depending on if you want to know about how much resources it consumes and all that stuff. But there are verification tools that are very specific for different specific needs. If you want to talk about configuration of network configuration, formal verifications, there are tools for that as well. It's about choosing the tool that you need. Most of these tools have open source alternatives as well, which allows for further customization, and it gives you the flexibility to define your own rules and patterns. As long as there's a pattern where there's a vulnerability, you can define what exact grammar of code or configuration that you want them to follow, and you can customize that, and you can let your team have a specific set of rules that can be internal as well, depending on what you're programming. So I'm just giving a tiny look under the hood of how these formal verification tools really work. This part might just be a bit more technical. Your programs are first generated into tokens, just like a compiler, like go-to statements, which is a very low-level representation of the code. In case of blockchain contracts, it's done in bytecode level. These are then converted into true-false Boolean expressions called semantic modular theories or SMT formulas. And these formulas are then solved against certain conditions called verification conditions. If satisfied, mean a vulnerability is present. These solves are usually done by SAT solvers, which are a separate kind of mathematical engines that are built as backend for these formal verifiers, and they are really important in solving Boolean equations. So thank you so much for attending my talk today, and hope you have taken something. We're open for any questions if we still have time. Yeah. Please.
In my experience, I'm not a developer. I've worked in IT security for many years. When you ask developers, in my experience, developers for many years, when you ask developers to run these tools, a lot of them, I think, have a fear that it's a personal attack on their ability, and there is, I've seen a certain amount of reluctance for people to be put under the spotlight on their work or their code to be put under the spotlight, because a lot of people working remotely, developing in their own bedrooms, spare rooms, and suddenly when you put a spotlight on them,
yeah.
It sort of, I think they fear, or there is a fear that it interferes with their creativity and their flair, because they've created something really nice, and yet somebody's saying that it's a bit rubbish.
That's a really good question, because as coming from a background of software engineer who's moved into cybersecurity, I really understand that particular point of asking us to do something where we point out the flaws and be like, hey, this is wrong, fix it. But here's the thing. Cybersecurity as a profession is a little bit different from DevOps, and that's different from software engineering. You each have your own expertise, and security is a collective issue. It's a collective responsibility. So it's not an easy conversation to approach in general, yes, but it's a challenge that we must overcome if our ultimate aim is to build secure software that works perfectly as intended. It's in fact, these tools, the formal verification tools that I've mentioned, are not things that work just like a compiler. So if a programmer makes any syntax errors, or when he's typing out and when he makes some kind of like spelling mistakes or something, it points out saying, hey, in this exact line of code, you made this mistake. This tool just takes it a step further and lets him or her know that there's a problem in these 3 lines of code. How about restructuring them somehow different? If you don't, this problem can occur. So when you break down the big problems as such, it can really help bring the team together to build secure software. So yeah, hope that answered the question. Thank you.